In this question, we are interested in finding the volume of the solid obtained by rotating the following region about x-axis. So let us identify what is the axis that we're trying to rotate about. This is our function, e to power x, and then y is equal to 0, and then x is equal to 0, and x equals to 1. So let us visualize this, see what do we have here. Graphing exponential function is not that difficult. We know that e to the x behave like this. And then y equal to 0, which is basically your x-axis. Then you have x equals to 0, which is your y-axis. And then x is equal to 1, which is basically your vertical line here. And then you are rotating this object about x-axis. Very good. So rotation about x-axis is not that difficult to see. This is the 3D object that you're getting. And remember that from the formula, the volume is the definite integral of a to b, the area dx. Our goal is to find the area of the cross section. What is a cross section? A random cross section. Let's take it here. You want to know what is the area of this circular object. The radius is what? The area is equal to pi r squared, if you assume this is r. But your r is located on e to the x. So the area of the cross section is pi e to the x to power 2. At the same time, area can be written as pi e to the x times e to the x is e to power 2x. So just substitute it back into the integral and find the definite integral. So this guy is x equals to 1. So we are ranging our x between 0 to 1 of pi e to 2x dx. Remember that we use u sub to find the integral of e to power kx dx. So when u is equal to kx, du is k dx, or dx is du divided by k. This is 1 over k, the integral of u du, or 1 over k e to power kx plus constant of integration. So k in this case is equal to 2. So this integral becomes a half times pi e to power 2x, and x ranges between 0 to 1. So volume is pi over 2 e to power 2 minus e to power 0. E to power 0 is not 0, everybody. E to power 0 is just 1. So you can write this guy, v, or the volume, as pi over 2 e squared minus 1. So this is the volume. If you want to see a number, you can use a calculator and approximate this. In this question, we have y equals to 1 over square root of x plus 1, and y is 0, x is 0, x equals to 1, and you're rotating this guy about x-axis. So let's try to visualize this as much as we can. Here we go. So here you have your x and y. When you hit x 0, your y becomes 1 over square root of 1, or just 1 divided by 1, or 1. So when x is 0, this function is at 1. When x is equal to, for example, 3, your y becomes 1 over square root of 4, or a half. So at 3, you have a half, right? What if I plug in a negative value? Well, if I plug in -1, I get 0 on the denominator that I don't like. If I plug in some more numbers like 8, you get 1/3 and so on. So it seems like my graph behaves like this. So I'm trying to just make sense of the behavior of this graph. And remember that when the domain of this function, if you want to think about the domain, x plus 1 must be more than 0. It means that x must be more than -1, and x equal to -1 is a vertical asymptote. So we know that at x equals to -1, it gets a vertical asymptote. And we know that it doesn't go further to the left-hand side, right? Perfect. So let's just skip this part. We don't need this. And just look at the positive part of this function. Very good. Y is equal to 0. So basically you have your x-axis, then y is equal to, and then x is equal to 0, which is your y-axis, and then you have x equals to 1. Very good. X equals to 1 is just right here. So we're looking at this region. You can forget about the rest of it. And we're rotating this about x-axis. So this is the object of rotation, and this is basically your cross section. Okay, for this disk, we need to find the area of this disk, which is pi r squared. Since you're rotating this about x-axis, r is located on this function, which is 1 over square root of x plus 1. So the area is equal to pi times 1 over square root of x plus 1. Don't forget your exponent too. And area is equal to pi divided by x plus 1. So far we found the area. Now we need to calculate the volume. The volume of this object is the definite integral of the area. And since we are rotating this about x-axis, we're going to use x. X ranges between 0 to 1. So we have the boundaries, and we know that the area is pi divided by x plus 1. Very good. So let us continue. The volume is the definite integral 0 to 1 pi divided by x plus 1 dx. But how do I take this integral? What is this integral? Remember that if you have the integral of du divided by u, it is ln of absolute value of u plus c. Your u in this case is x plus 1. So this can be written as pi ln of absolute value of x plus 1, and x ranges between 0 to 1. First, plug in 1, then plug in 0 and do the calculation. The volume is equal to pi ln of absolute value of 1 plus 1 minus, so let me put this here, ln of absolute value of 0 plus 1, close the parenthesis. The volume is pi times ln of absolute value of 2 minus ln of absolute value of 1, or we know that both 2 and 1 are positive numbers, so it is equal to pi ln of 2 minus ln of 1, but remember that ln of 1 is always 0, so this guy is pi times ln of 2. Again, to get an approximation, you have to use a calculator because ln of 2 is a decimal number. So pi, another decimal number, multiplied by ln of 2, it's better to use the calculator to do an approximation.